Any questions on that algebra there? Just moving stuff around. And what do you do on the right side now? Factor out a y prime. So you're left with 1 plus x over y squared, secant squared x over y. And then on the other side, 1 over y, secant squared x over y minus 1. And finally, divide through. So divide everything, both sides of the equation, by that stuff on the in parentheses on the right side. And you could probably go further with this, but I'm going to stop here. I mean, like if you would check it in the back of the book, they might clean that up a little more. Hold on, let me finish writing this and make sure. Do what? Multiply y squared where? Like right here? Like right here? Multiply both sides of the equation by y squared? You could have done that, that's fine. See, that's what I would do at this point right here. I would actually multiply the top by y squared and bottom by y squared and distribute it through like that. So. But I'm not going to go that far. All right, I think that's sufficient for getting us started with the quiz. All right, anybody else? Last call? So the first problem on the quiz was very similar to number 7 on the homework on page 127. I just changed, the one in the homework is y cosine x. I made it x cosine y. And then instead of x squared plus y squared, I put x squared plus y cubed. That was the only difference in the problem. On number 2, well, that was on your formula sheet if you had it sitting in front of you. So the derivative of e to the x and derivative of natural log of x are on your formula sheet. And that's part of what you were supposed to watch with the videos for today. And then number 3, when I was at the funeral, I had asked you all to watch those lectures from the fall. I did number 3 in those videos, but I did it backwards. I did, instead of asking for how fast the radius is increasing, in the video I said how fast is the volume increasing. So it was just switched. You know, the d, instead of wanting to know dr dt, like the quiz, the one I did in the video, I asked for dv dt. So, all right. I'm going to post the solutions to these later today. All right, when I post the video, I'll put out like the notes I usually do, and I'll put the solutions to the quiz out there. All right. So what is the derivative of e to the x? E to the x. And what is the derivative of the natural log of x? 1 over x. Those are two very important formulas to know today as we move forward. We do have some stuff here. Again, I'll post this later. Today we wanted to do a quiz, answer any homework questions, cover problems from 3.3 and 3.7. There's going to be no homework out of 3.1 and 3.2. If you watch the videos on those are really short. It was just to get you acquainted with what e to the x looks like, what natural log of x, what exponential and logarithmic functions look like when you graph them. But everything I said on those videos for 3.1 and 3.2, you should know. Okay, like everything I stated there, because it's very short and to the point, but those points you need to know. Then next time, you'll watch the videos for 4.1, 4.2. Those are the homework assignments for 3.3, 3.7. And then remember how I said I'm going to give you like a problem or two out of those word problems, so we keep on practicing them. There's number 27 and number 28 are 2 problems to do from related rates. All right. So let's get into what today is about, and that is 3.3, which is the derivative of exponential and logarithmic functions. So this is 3.3. Derivatives of exponential and log functions. So if you're looking for like a main formula, all right, of what this section is about, if you're looking for the main ideas, here they are. If you take the derivative of a constant, so a is a constant here, raised to the u. Now you can use like our junk. Remember how we've had junk in the past? So if you've got a number raised to something, the derivative of that is itself a to the u times natural log of a times u prime. Now there is a special case when that a is e. Now e is a very special number, right? If this is e to the u, then the derivative of e to the u is itself times natural log of e times u prime. But what is the natural log of e? 1. So this just turns out to be e to the u times u prime. So you could kind of say it like this. The derivative of e to some junk, right? The derivative of e to the junk is e to the junk times the derivative of the junk. Right? That's what it is. Now the quiz problem, right, so this is a little different. The quiz problem was what's the derivative of e to the x, right? Well, according to this formula, the one there in red, it's kind of hard to see that that middle one's red, is e to the x times x prime. But what's x prime? 1. So we wouldn't write x prime. It would just be e to the x. And that's what makes e to the x such a great function. I mentioned this in the videos. E to the x is the only function other than the 0 function that is its own derivative. All right, now, so the black one up there is like the most general idea behind derivatives of exponential functions. The red one there is if you have e to some junk, and then the green one is if you have e to the x. With me? Okay, then we have the logs. So I'll do this one in black also. The derivative of log base a of some junk is 1 over the junk, natural log of a on the bottom, times the derivative of the junk. And a lot of times books will put the derivative on top, like this. Just slide it over. That's the general formula. If we use a specific base of the log, and the base that we love to use is the e, log base e is actually the natural log. So we would never write it that way. We actually would write this, natural log of u. Okay? So what is the derivative of natural log of u? It is u prime over u times natural log of e. But what is natural log of e? 1. So this just becomes u prime over u. Try and make this real quick. You see this log base e of u? Like if it was log base 2 of u, it could, there's all sorts of different logs. You can have different bases, right? 2, 4. As long as the number down there is positive, okay, you can have bases for logs. The reason why we use this notation, natural log of u, instead of log with the little subscript e, the only reason we do that is because back in the days before computers, when people used to use typewriters, they would have to use, the natural log function always occurred, like it was always coming up in research and stuff, and so you'd have some chemist who's doing all this work and it's got a bunch of natural logs in it, and instead of, if you've ever had to subscript on a typewriter, has anyone ever used a typewriter? Have you ever had to subscript? You have to do a little half rotation of the drum and then type and then back, and it slows the process down. So what they did is they agreed that we would use this in the yellow here. We'd use that as like the shorthand notation. So that way you could just type and never have to stop and do that. But that's the only reason, okay? It's kind of a weird little fact. All right, now I'm going to do in green what we get when our junk is just x, right? So what's the derivative of log base ex? Well, again, we would never write that. We would write what instead? ln x. The derivative of ln x is x prime over x, right? Natural log e, but natural log of e is 1, so it's just x prime over x, but what's x prime? 1. 1 over x, which was the answer to the quiz problem. But again, that's a formula on your formula sheet. So in my opinion, every Cal 1 student should know that the derivative of the natural log of x is 1 over x. But it's more valuable for you to know that one in black, because then you can take the derivative of any log. With me? Okay, we're ready to do some examples now. So I'm going to be working off of out of section 3.3, and I'm going to start with number 2. The problem is f of x equals x natural log x minus x. Find f prime of x. So we are not going to use implicit differentiation. Remember implicit differentiation? That's what the quiz was over just a second ago. That's when your y's and x's were mixed up in an equation you could never solve for y. Here, you could almost look at this as being like y equals the right side, and the right side just has x's in it, right? So this is really asking for y prime. So it's just a straight derivative, treating x like the independent variable. So what do we see on the right-hand side here? I'm going to take the derivative. Y prime equals, what's going on the right side? Product rule. The product is happening right in between the x and the natural log of x, right? And then separated from that is minus x. So I can go ahead and take care of the minus x. I'll just throw it out here. What would I get if I took the derivative of negative x over here? Just minus 1, right? But I have to still do the derivative of the x times natural log of x, which is product rule. So what's the derivative of the first one? What's the derivative of x? 1 times ln x plus, now what's the derivative of natural log x? 1 over x times, finish off the product rule, x. And so what you get is natural log x plus 1 minus 1. Because 1 over x times x, right? 1 over x times x is 1. So this just turns out to be what?